Good day everyone. I'm Bachelor from BSCE 3B. We are tasked to pick two problems in our subject Electrical Machines 1 in partial fulfillment of the course requirements in EE 311 Electrical Machines 1 for the degree of Bachelor of Science in Electrical Engineering. Overview. What is a DC motor? A DC or direct current motor is a type of electrical machine that converts electrical energy into mechanical energy through the interaction of magnetic fields. It operates based on the principles of electromagnetism and relies on the flow of direct current to produce rotational motion. There are four parts of a DC motor. There are stator, rotor, or the armature, brushes and commutator, and operation. Stator, it is the stationary part of the motor. It typically consists of permanent magnet or a set of coils that generate a magnetic field when an electrical current passes through them. A rotor or armature, the rotating part of the motor. It is usually made up of a coil of wire wound around a core, and it is free to rotate within the magnetic field produced by the stator. It is also connected to the power source, and when a current flows through it, it generates its own magnetic field. Brushes and commutator. In DC motors, brushes and commutator are used to ensure the continuous flow of electric current in the rotor. Lastly, operation. When a DC voltage is applied to the motor, current flows through the coil in the rotor, creating a magnetic field. The interaction between this magnetic field and the magnetic field generated by the stator causes a torque that results in the rotation of the rotor. As the rotor turns, the commutator and brushes ensure a continuous flow of current, maintaining the rotation of the motor. Yan po yung overview about DC motor. Yan yung parts na. Ito po yung given problem, yung na-choose ko po. Tutorial problem 29.2, problem number 3. A DC shunt machine has an armature and field resistances of 0.025 ohms and 80 ohms respectively. When connected to constant 400-volt bus bars and driven as a generator at 450 RPM, it delivers 120 kilowatts. Calculate its speed when running as a motor and absorbing 120 kilowatts from the same bus bars. B. Deduce the direction of rotation of this machine when it's working as a motor, assuming a clockwise rotation as a generator. Given RA for the armature resistance 0.025 ohms, field resistance 80 ohms, volts 40 volts, speed N1 450 RPM, PL equals 120 kilowatts or 120,000 watts. Required is N2 or yung second speed. Solution and answer. Una, hanapin muna natin yung current. Para makuha, ang formula is PL over V. Yung PL nasa given kanina is 120,000 watts over 400 volts equals 120,000 divided 400, 300 amperes. Yung sa naman, current na sa shunt, V over RSH. 400 volts divided by 80 ohms equals 5 amperes. Yung sa generator naman, para makuha natin yung EG. V plus yung armature current times the resistance current. So, pwede rin tong gamiting formula nasa baba. Same man lang yun. So, 400 volts plus 300 amperes plus 5 amperes times 0.025 ohms equals 407.625 volts. Next, kunin natin yung sa back EMF. Ang formula naman ng EB, V minus IA times RA. Same lang yan dito sa V minus IL minus ISH times RA. So, 400 volts minus 300 amperes minus 5 times 0.025 ohms equals, yung back EMF niya ay 392.625 watts. So, para makuha naman po natin yung M2, which is yung speed, kailangan natin itong formula itong EV or the back EMF over EG or yung sa generator equals N2 over N1. So, pag yan natin yan, para makuha natin tong N2, ang kakalabasan ay N2 equals EB times N1 over EG. So, ito na siya. N2 solve natin 392.625 volts times 450 RPM over 407.625 volts equals 433.440664 RPM or ang nakuha po natin speed ay 433.44 RPM. Next, so yung B, ito yung question kanina na pangalawa. Reduce the direction of rotation of this machine when it's working as a motor, assuming a clockwise rotation as a generator. So, ang sagot po natin dito, by Fleming's left-hand rule, the machine's rotation while operating as a motor occurs as a clockwise direction. So, clockwise po siya. Next number naman. A DC shunt motor runs at 900 RPM from a 400 volt supply when taking an armature current of 825 amperes. 25 amperes. Calculate the speed at which it will run from a 230 volt supply when taking an armature current of 15 amperes. The resistance of the armature circuit is 0.8 ohms. Assume the flux per pole at 230 volts to have decreased to 75% of its value at 400 volts. So given N1 900 RPM, V1 400 volts, V2 230 volts, IA2 or yung armature current 15 amperes, IA1 25 amperes, or yung armature current, yung armature resistance 0.8 ohms, yung flux 1 siya, yung flux to 75% or 0.75 required, yung N2 ulit, yung speed ang hinahanap. Solution and answer. So, ang formula para makuha yung AB1 equals V1 minus IA1 times RA. Itong IA yung sa armature current 1. Same lang siya sa EV2 pa. Pinalitan lang ng 1 yung 2. So, isolve natin. Yung sa EV1, V1 minus IA1 times RA. So, 400 volts minus 25 amperes times 0.8 ohms. So, 380 volts po siya. Ito naman sa EV2 or sa back EMF. V2, 230 minus IA2 or yung 15 amperes times 0.8. So, ang nakuha po natin ay 280 volts lang. Para naman makuha natin yung N2 or yung second speed, gamitin po natin tong formula na EV1 equals KN1 para makuha natin yung N2. So, K equals EV1 over N1 or speed 1 times flux 1. Yung back EMF2 equals yung constant times N2 times yung flux 2. So, EV2 or yung back EMF2 equals EV1, the quantity EV1 over N1 flux 1 times N2 times flux 2. So, magiging ang formula, dito natin kukunin yung formula. N1 flux 1 EV2 over EV1 flux 2. So, ang natin, formula para sa N2 or yung speed, pero natin yung speed, N1 times flux 1 times EV2 or yung back EMF2 over EV1 times flux 2. So, i-compute natin siya. 900 RPM times 1 times yung EV2 which is 218 volts over 380 times 0.75. So, 688 hindi nakikita. Basta ang sagot 688.4210526 RPM. So, ang speed natin ay 688.42 RPM. Yan lang po. Thank you po.